Welcome back. In this lesson, we're going to look at minerals, how minerals are put together, and how would you identify one mineral from another. So minerals, I think of as Legos that you would put together to turn into rocks. Those minerals themselves have been made up of atoms and different compounds put together, and they come into crystal form in different ways, and we'll look at those. And then how do you tell one crystal from another? There's a number of tests that you can do to determine that. So let's look at some examples. So a mineral has a specific definition, and there are things that you would assume is a mineral that is not, because it doesn't meet the criterion, and there's other things that you would think would be a mineral that actually isn't. So this is a geologist's definition of a mineral. It has to be naturally occurring, right? So, for instance, ice is considered a mineral as long as it's naturally occurring ice. If you make ice in your freezer, it's not considered a mineral. So that's pretty interesting. So it has to be something you can dig up, has to occur naturally on Earth, right? It has to be a solid. So, for instance, bromine is a liquid. It can't be a mineral. Even though you might find a vein of bromine in a rock or in an ore, it can't be considered a mineral because it's not solid. It can't have carbon in it. Inorganic is carbon, or inorganic means no carbon. So it can't have carbon in it. So coal is not considered a mineral, even though it's considered one of our mineral resources. Okay, it's not a definition of a mineral. And so we'll look at some of these in detail as we go through. There's about 3,000 minerals, but you don't learn 3,000 minerals. Even a college professor probably only knows a few dozen minerals. So there's lots and lots of very rare minerals of different Legos that can combine in very, very unique ways. But most of the minerals on Earth that make up the rocks are in about 30 different types. There's about 30 different types of minerals. So let's look at these definitions one at a time. It has to be naturally occurring. Okay? It has to be organic. It can never have been alive. So organic usually means carbon-based, so anything like plants or animals are mostly based out of carbon, the element carbon, and so that would not be a mineral if it were one time living. It has to have a definite crystal structure. Okay, so it forms a structure, a crystal, that is then identifiable. That when you looked at it under a microscope, you could see a specific shape that it comes into. So a lot of times, large minerals, you can see shapes. Like this is a piece of amethyst quartz, and it forms a very unique hexagonal kind of pencil looking shape. And so it's, when you see it, you're like, oh, I know what that is. That's quartz. Okay, so they're solids, and they grow. The little molecules or the formula units inside the compound grow in a very definite way. So they also have a definite composition, meaning they have a recipe. So salt is NaCl. And all table salt is NaCl, sodium chloride. It is always going to be that formula no matter where you find table salt on the Earth. It's going to be the same. 1,000 minerals in the Earth's crust, there really are only a couple dozen that are very common, the great percentage. You have lots of rare examples because you can make any combination of Legos, but most of the materials are going to make in the same ways. And so you're going to see about 30 common minerals. So there are different ways that minerals form. You can form from magma. Magma, remember, is melted rocks. So this would be under a volcano. And as you cool that magma down after a volcano has erupted, or in the case of under the ground, if the hot spot moves away and it cools down slowly, then the minerals can come out of solution and form as solid minerals. You can also have solutions, so something dissolved in water that very slowly then comes out of solution and forms forms definite crystals. So your crystals all have very specific shapes. The kinds of atoms that come together form crystals in very definite geometries. So, for instance, you can have a cubic shape like table salt, or you can have hexagonal shapes like the quartz we mentioned, and that can help you identify them because they will always, if given enough time and slowly growing, they will grow exactly the same each time because that's how they're made. So you can identify them based upon all kinds of different things. You can identify them based upon the crystal that they make. Like a certain crystal, if you see that shape, it's a dead giveaway that you have it. You can identify it based upon the way it reflects light. That's called luster. So whether it's metallic looking or glassy looking or dull or clay-like, that's a way you can identify them. Hardness is resistance to scratching. So how easily is it scratched? What can scratch what? These are hardnesses, and a mineral will have the same hardness all the time. So it's an easy way to identify a mineral based upon its scratchability, if that's a word. Also, because of its very specific crystal shape, a lot of times these atoms will all line up along a plane. And so if you were to hit a rock, sometimes it'll break along that plane. And so it'll crack along that weakness, that weak spot. And that's called cleavage. Cleavage is where it all splits along or splits along a weakened part. Fracture is when one is not as, they're about the same in terms of how easy to break, and so it actually breaks very jagged and rugged, like you would imagine many rocks. Streak is when you scratch a rock on this is a streak test picture here on the left, where you scratch a rock on a piece of porcelain, and it basically crushes that rock into powder, and then you're looking at the color of the powder. Because color, even though color is possible of identifying a rock, sometimes the outside of a rock will have a chemical reaction with the air and change color. So the outside of a rock is a different color than the inside of a rock. There are also special properties. Some cases will, like an opal here on the left, it's iridescent. That's an easy giveaway that that's an opal. A piece of calcite, which is like Iceland spar, double refracts. So if you were to see something underneath it, you're going to have basically two images. Also texture. Does the mineral feel greasy? Does it feel smooth? Does it feel ragged? These are ways. And then the last one that's used a lot is its density or specific gravity. So comparing a ratio of its mass per unit volume based upon water's mass per unit volume. And so all of these ways are ways that you can identify one mineral from another.